For this video, we'll be focusing on chapter 24, section 3, which is about the mutarotation of glucose. Mutarotation is the interconversion of alpha and beta anomers. We have a ring structure with the sterocenter, and we want to change that sterocenter. In our case, we start with alpha D-glucopyranose, and we do a mutarotation to form beta D-glucopyranose. There are two steps in mutarotation. The first is to open the ring structure, and the second is to form the ring. Breaking and reforming can be done in acid or base. The acid catalyzed form will be shown first. The OH in red will be changing from an axial position to an equatorial position. First, the oxygen in the cyclic structure grabs a hydrogen, creating a positive charge on the oxygen. Also notice that the arrows forward is shorter than the arrows in reverse. This is because forming the non-ring structure is less stable and therefore unfavorable. The oxygen donates its electrons so the ketone can take the electrons from the carbon-oxygen bond. For the ring to break, there needs to be an atom that donates its electrons to the carbon in the carbon-oxygen bond being broken. The ring is now broken, and the hydrogen on the positively charged double-bonded oxygen is now removed using water. This results in a hydronium ion and an uncharged open structure. Now for the second step. The aldehyde grabs a hydrogen, creating a positive charge. The oxygen on the alcohol group donates its electrons to the aldehyde, which results in the breakage of one of the bonds in the double bond between the oxygen and the carbon, and thus the donation of the electrons to the positively charged oxygen. The ring is now reformed. Note that the new ring formed is still a six-membered ring. This is because it is the most stable and therefore will form most easily. The water takes the hydrogen on the ketone to make the acid catalyst. This reaction results in the change in the ring structure. The OH is now in the beta position. Now for the base catalyzed reaction. We'll use a water molecule for this example. First, the oxygen in the ring attacks the hydrogen in the water molecule, which makes the water molecule lose a hydrogen and become a hydroxide ion. With 3 bonds, the oxygen now has a positive charge. The hydroxide ion then attacks the hydrogen in alcohol, shown in red. The electrons then transfers onto the oxygen, which allows the oxygen to have a double bond. Then the bond between the carbon and the positively charged oxygen breaks, and the electrons are transferred to the positively charged oxygen, making it neutral. The ring is broken, and we have water as a side product. Now that the ring is broken, the lone pair of electrons in the alcohol attacks the carbon with the double bond. This causes one of the bonds between the carbon and oxygen to break, transferring the electrons to the oxygen. The ring is now reformed, but the oxygen in red now has a negative charge. This oxygen will attack the hydrogen, which is bonded to the positively charged oxygen in the ring. This results in a breakage of bond between the hydrogen and the positively charged oxygen, transferring the electrons to the oxygen. Finally, we are left with a beta position OH and water as a side product. Thank you for watching.